Hey friends, welcome to NIKRA'S Expert Learning. Today we are going to start a new series of design of prestressed concrete members, that is DPCS. Okay, so here we are studying about what is a prestressed concrete, the applications, and whatever the problems involved in this DPCS, we will be solving that in the new series. So coming to the introduction part, we call Prestressed as the father of prestressed concrete. Okay, Prestressed is the father of prestressed concrete. As per IS code 1343-2012 and IS code 456-2000, we would be analyzing the prestressed concrete members. Okay, so here we are using the main code, that is IS 1343-2012. And the previous edition is IS 1343-1980. So initially it was in the year 1980, but here we have the updated version in the 2012. Okay, so why, what and how we can go with this prestressed concrete members, and why we are choosing this over the nominal conventional method of the concrete structures, and what are the advantages of using this. So we'll be seeing this now. The biggest advantage of PSC members is it can be used for larger spans. So we can see that the prestressed concrete is ideally suited for long span bridge construction. So for knowing what is prestressed concrete, we need to know the principle of prestressing. So initially let me first explain you what is a prestressing principle. That is inducing the compressive stresses in order to counteract the tensile stresses developed due to the service loads. So whenever the service load acts on the member, the generation of tensile stresses would be happening. So initially we are inducing the compressive stresses to counteract these tensile stresses. Okay, so what is a prestressed concrete? The prestressed concrete is basically concrete in which the internal stresses of a suitable magnitude and distribution are introduced, so that the stresses resulting from the external loads are counteracted to a desired degree. So in this, the reinforced concrete members, the prestressing is commonly introduced by tensioning the steel reinforcement. So in the normal reinforced concrete members, we are just providing the steel reinforcement, and after that we are just laying the concrete on that. But here we are doing nothing but the tensioning of the steel reinforcement prior to the application of concrete. Okay, so here we are inducing the compressive stresses. So this will counteract the depression or the deflection caused due to the service loads. See here, because of the compressive stresses, we are getting a hogging curve, but because of the service loads, we will be getting a sagging curve. It will be counteracting this both sagging and hogging movement. So here the neutral state will be formed. This is a neutral form. Okay. So here in the prestressed concrete structures, we use high strength concrete and high strength steel. So I'd be explaining you what is the advantage of using this and what is the necessity of using this high strength concrete and high tensile steel. Let us now see what is a cable. So generally when we call wire, we are specifying a high tensile steel single wire having a diameter of 5 mm, 7 mm, 8 mm, etc. And when these wires are grouped or binded together, we call that a strand. Okay, see here initially we are calling each one as wire. Together we are calling that as strand. And a group of strands is called as tendon or cable. Okay, so this is a cable. So depending upon the load acting, we can also select the cable profile. That is the axis of provision of cable. Okay, so we have different types in that. We will be seeing one by one right now. We have different types of cable profiles and are mentioned below. First of all, we are having straight cable. Straight cable it is further classified as concentric and eccentric. As we know, concentric is nothing but it passes through the centroidal axis of the member. Eccentric is the distance of E from the center. Okay, from the centroid it's some eccentricity. Next we are having parabolic cable. Even in this we are having two subdivisions, like let us say parabolic cable with single eccentricity. That is at the mid span it is having some eccentricity, but at the corners it is passing through the neutral axis only. But whenever we are talking about the double eccentricity, that is it is having eccentricity at both mid span and supports. See here, initially it is having mid span, at mid span it is having eccentricity, and also at the supports it is having some eccentricity. Next, let us see what is the cable profile of in a triangular shape. In this triangular shape, we are having a triangular cable. We can also call it as a bent cable. Okay, and eccentricity at mid span. Here we are having double eccentricity, single eccentricity, double eccentricity. Next we are having a trapezoidal cable profile. So when there is force distributed through the CG, the center of gravity of the section, then there is only normal stress induced. So whenever the force is acting along the centroidal axis, there is only normal force. But whenever it is eccentric, because of the eccentricity of that load axis, there would be development of normal stresses, also the bending stresses. Coming to the sign convention, so remember here in this case, whenever we are talking about compression, it would be of positive sign and tension is always negative. From figure 1, here we are showing how we are inducing the compressive stresses. So we see only normal stress, the stress is equals to load by area. We know the normal stress is equals to load by area. But here, remember also the P is nothing but the pre-stressing force. It can be either in kilonewton or newton. Area is the area of the section, the area of the cross section of this member. Okay, it can be of units mm square or meter square, that is B into D. Okay, but when we are talking about this figure 2, we can see some eccentricity of the tendon from the CG of the section. So here from the above figure, we can see that the tendon profile is straight cable having eccentricity E. So here, along with the normal stresses, there also exists some bending stresses. We know how to get the bending stress value. So we derive the bending stress formula from the bending equation. We know the bending equation, right? M by I is equals to sigma by y is equals to E by R. So here we can get, from considering these two terms, we are ignoring this, and from these two terms we know the stress, bending stress is equals to M multiplied by Y divided by I. We know I by Y is nothing but Z, the section modulus. Okay, so now we have the normal stress plus bending stress is equals to P by A plus M by Z. I told you whenever we are talking about compression, it is positive. But whenever we are talking about the tension, it is negative in sign convention. So here, we know at bottom, so in general members, whenever we are talking about RCC members, we know at bottom we are having tension. Okay, at top we are having compression. But here in the prestressed concrete members, it is vice versa. So here, we are having compression at the bottom face, at the bottom fiber. So here the stress is P by A plus M by Z. In the top fiber it is negative sign. Okay, here the bending is in negative direction. We are having some methods of pre-stressing, that is pre-tensioning and post-tensioning. Pre-tensioning is nothing but, here the stress transfer is mechanism of bonding. Here the stress transfer is anchorage. That is, in the pre-tensioning, here the stress transfer mechanism is bonding. Through bonding we are transferring the stress. Whatever the compression stress we are inducing to the member, it is transferred through bonding. And in the post-tensioning, it is transferred through anchorage. Minimum grade of concrete. For pre-tensioning, we have to go for M40. For post-tensioning, we have to go for M30. Remember, for pre-tensioning, the minimum grade of concrete is M40. For post-tensioning, it is M30. It is a very important bit question that can be asked in any sort of competitive exams. That is it for this video, guys. In the next video, we will be discussing what are the methods of pre-stressing in detail, like pre-tensioning and post-tensioning, systems of pre-stressing, whatever the Magnal-Batten, Lee-Meccal system, Hoyer system, the losses of pre-stressing, and here we are having some anchorages in this post-tensioning. We'll see the types of anchorages also. So if you like this video, please like, share and comment to the channel, guys. Only 0.5% of users are subscribing to the video, guys. If you like this video, please do subscribe, and if you don't like, please let me know what is the reason behind you not subscribing to my channel. That is it for this video, guys. Thank you for watching this video.